till 2024 and in future also. Okay, so short, brief history I am going to put in front of you. So in 60s and 70s, rule-based systems. Rule-based in the sense, so a program which is written based on the if then else conditions. जसं आपल्याकडे वॉशिंग मशीन असतं घरामध्ये, तर त्यामध्ये डिटर्जंट किती अमाऊंट पाहिजे, वॉटरचा अमाऊंट किती पाहिजे आणि ते पिस्टन किती वेळा रोटेट होते, त्याला EEPROM. Okay, you might have studied in fundamentals of computers. EEPROM. Where the program is generated and based on the rules, if this is the condition, this action to be taken. If this is the condition, this action to be taken. Like this. So here, so this is okay. This particular part. And now focusing. This is the rule-based system which was developed. Okay. Okay. So that was the rule-based system that was developed in 1960s and 70s. Later on, statistics involved in this. Okay, in 80s, statistics came where it has supported many things for the natural language processing. Okay, CORPA. So this is what I'm going to focus on this word. CORPA. The meaning of that word is the massive database. Massive, there is no size for that. Now, I am going to show you some millions and billions of language models are there in the world. Okay, by using those data sets, the research is going on still. So you can develop your own language model also, but it takes a lot of time. So from the 80s, we came to the 90s. Now the word specific linguistics, corpus. Okay, linguistic stands for language. Okay, so these are the models. Now in machine learning, we are using hidden Markov model, support vector machine that have been supported a lot for sentiment analysis, classification of different models. Okay, one by one we are going to see. In 2000, machine learning and neural network came into the NLP. Okay, so the researchers have contributed their research by using machine learning algorithms as well as neural networks. So here the most of the staff knows what is the neural network. Okay. So again, 2010, deep learning has been came into that. Okay, OpenAI, ChatGPT. Okay, all these are the pre-trained models. Discussing with the sir. Sir, this is the BERT. BERT is a pre-trained model of ChatGPT. So these models directly you can use it. Okay. So later on in 2020s, this has been progressed a lot in NLP. Okay, machine learning, algorithms, deep learning, all this. They are developing that one. Okay. Now here there is a new concept of natural language processing. One is NLU, another is NLG. NLU stands for natural language understanding. NLG stands for natural language generation. Okay, is the process of producing meaningful phrases and sentences. Suppose if I say like this, okay. John is gone to school. Am I right? Grammatically, Santosh is sitting here. He made judgment. John has gone to school. This is completely grammatically wrong. So the thing is that it should produce meaningful phrase. Okay, there is a concept comes here that root word or a base word will be come. I come to that point later on. Okay, so whatever sentences, phrases that are generated through the program or through the machine learning, so that should be meaningful. It should be grammatically correct also. It is not like that simply the statement is generated and whether it is grammatically right or wrong, that doesn't matter. But the sense is that it should be meaningful, it should be grammatically correct. The system has to do this one. Okay. So it involves text planning, sentence planning. Text planning includes retrieving the relevant content of the knowledge base. Knowledge base in the sense it is a database. Okay, from the database, you are retrieving the exact meaning of that word. Okay, sentence planning, it includes choosing required words, forming meaningful phrases. So that meaningful phrase, it may be repetitively coming into the slide. So take it as a granted. Okay, so text realization, it maps the sentence plan to the sentence structure. Sentence plan is different, sentence structure is different. Okay, structure comes under the morphology, lexicon we will call. So I will be coming to it. So difficulties in NLU. NL, natural language processing, has extremely enriched form and structure. As I said, there are many languages around the world. French is there, German is there, Arabic is there. Okay, and in Indian scenarios, there are many languages. The most difficult is Arabic and Urdu. Is very difficult to train the machine. Okay, to train the Arabic and Urdu is very difficult to train the machine. Still, the people are working on that. So in my slide, whatever important things are there, there will be some other things. Okay. So this type of indexing I have drawn. Okay. Now let us see here. Let's see the activity. It is very primitive level, such as word level, means basic level. As I said, John is going to school. John, that is a noun. Okay. In English, we are having vowels. Okay, and the grammatical categorization also. Okay. Noun, pronoun, adjective, and many things, prepositions, and all those things. So when we write a program, the program should identify what is article, what is noun, what is pronoun, what is conjunction, what is preposition. Like this complete tree structure it has to generate. Okay, that is what. So if you see here, syntax level ambiguity, a sentence can be phrased, parsed in different ways. Now there is the example. See the ambiguity of the sentence in the language. So see here, he lifted the beetle with the red cap. This is my statement. Okay. Now did he use the cap to lift the beetle, or he lifted a beetle that had a red cap? Only one person has been recognized correctly, that is English level. Are you getting my point? Yes. How will you? Now, we are confused as a human being. Now, why not system? Definitely. The system has to generate. Okay. So, that was the one example. Now, referential ambiguity, how it is? So, a person using pronouns. Now, if you see, Rima went to Gauri, she said, I am tired. Exactly know who is tired, Rima or Gauri. How will you extract the context? Okay, so like this, these are the ambiguities in the statements, in the sentences. Those ambiguities are to be removed by writing the program. So that is why we call that as a natural language processing. Okay, so moving to this. So NLP terminologies. What are the terminology of NLP? Phonology, it is the study of organizing sound systematically. So you can understand better. There is a word called as phonetics, which is referring to, yes, okay, synonym and antonyms also we will call sometimes. Okay. So morphology and morpheme, these two things are totally different. Okay. Morphology is the study of construction of words primitive meaningful. Okay, and morpheme, it is a primitive unit of meaning in a language. Morpheme. Okay. Next, syntax, it refers arranging the words to make a sense of the sentence. The structural role of the word in a sentence and the phrases. Semantics, we know very, very well. Computer science people can understand what is semantics. Semantics and syntax. Okay. Semantics, it is concerned with the meaning of a word. Combine words into meaningful phrases and sentences. Phrase is a different, sentence is a different again. Okay. So pragmatics, it deals with using in sentences in different situations, how the interpretation of a sentence is affected. Okay, if I say a word, no, what is the spelling of that one? Yeah. NO and KNOW. Do you agree with me? So this course, it deals with how immediately preceding sentence can affect to the next sentence. Okay, there is a sentence, first sentence, and this sentence, how it is affecting to the next coming sentence. Okay, that is this course. Word knowledge, it includes general knowledge about the database. Okay. So these are the steps: lexical analysis, syntax analysis, semantic analysis, discourse of integration. I am not going to read whatever I kept here. The same thing is there in the next slide. Okay, just with the certain explanations. Now, this is about the flow chart of NLP. The first step: lexical analysis, syntax analysis, semantic analysis, discourse of integration, and pragmatic analysis. Pragmatic analysis doing what said, reinterpreted or what is actually meant. Okay, so with this, we'll come to this part, implementation aspects of syntactic analysis, how it is to be implemented. Okay, so there are a number of algorithms researchers have developed syntactic analysis, but we consider only the following few things: context-free grammar, top-down parser. Okay, parsing normally we will use when we come across the compiler design. Parsing technique sometimes we use in the DBMS also. When a query is fired, the query should be parsed in operating system also. So it is a grammar that consists of rules with a single symbol on the left hand side of the rewrite rules. I will tell you what is that. It is a grammar, okay, with a single symbol. What is the symbol? I will tell you. Now, it is an article. Okay, if I say job, it is a noun. Going, it is a verb. Okay, like that, we need to make context-free grammar. Okay. So, let us create a grammar to parse a sentence. What is my sentence now? This is my sentence. The bird and the grains. Bird and grains are noun. There is an article. Okay, that's in the verb. Okay, so let us see how it is. Article and so I go back. What I said, the single symbol on the left hand side. We are writing the rules now. Okay, we are writing the rules. So that is what this sentence is indicating. This one here. I am indicating with DET.
Determinant.
Yeah, determinant. Okay, A and the nouns. See here, bird, birds, grain, grains. Now, this is the alternate word for this one. There may be one bird, there may be many birds. There may be one single grain, or there may be a bunch of grains. Okay. Now, noun phrase, how it is created? See, combination of article plus noun plus article plus adjective. So this is how the noun phrase is created. Okay. Determiner, okay, noun, determiner. This is not the symbol we are creating. This is the context-free grammar. Okay. Word, text, packing, pack. All these are the these two are the alternate words. Now, which is the base word? Text. Okay, this is now here in natural language processing, we call this as a root word or a base word. And pecked and pecking are the alternate words for. Okay. Now, word phrase, how it is created? Noun phrase, word, or noun phrase. Now, adjectives. What are the adjectives? Beautiful, small, creepy. Okay. So these are the adjectives. Now, our system has to understand what is noun, what is pronoun, what are the base words, what are the root words, and all those things. This is what the concept comes in natural language processing quite like this, for generating the context-free grammar tree in Belcom. I'll show you here in the slide how the tree is constructed. So the parse tree breaks down the sentence into structure parts so that the computer can easily understand and process it. Okay. So in order for parsing algorithm to construct a parse tree, I will show you tree also how it is constructed. Okay. So which describes what tree structures are legal need to be constructed. By generating the tree structure, you need to generate the context-free grammar very clearly. Then the tree can be plotted. So here it is. This is what I'm using the symbol now. Okay. Now this S. S stands for sentence. Okay. What is NP now?
Noun phrase.
Noun phrase. What is NP?
Word phrase.
Word phrase. Okay. So NP is generated with the determinant, the noun and again adjective. Word phrase with word and noun phrase. Okay, lexicon. Now all these are my lexicons. Those who have studied comparative design, you might be aware with these words. Lexicon, semantic, syntactic analysis. Okay. So determine the adjective beautiful and preachy. Then bird, trees. And word is pet, pets and pecking. Pets and pecking is alternative words. What is my base word? What is my root word? Peck. Peck is my root word. Okay. So here it is. This is the tree. Have a look at this. What is the SP indicating? The root? Sentence phrase. Okay. What is the NP? Noun phrase. What is determinant? This is all. Yeah. This was my sentence. What I have quoted. The bird pecks the grains. This is how the output should be. Literally, I'm speaking. This can be generated in the Python very easily. There are some simple codes of it. I'll show you if time permits for me. Okay. This is how the tree can be plotted. Okay, you can use the Jupyter notebook or Google, Python or anything. Okay. Some fundamental aspects. Tokenization means I am breaking my words. Now, for example, I am taking only one single word, John. I will break J, O, and character by character I am breaking. Okay. Next, so tokenization comes character by character, word by word, and sentence by sentence also. This is the level of tokenization. Okay, suppose if I say the sentence quite like this: John is going to school. Now I break John separately, is separately, going separately, and school separately. Means now this is a word tokenization. Previously, I have break only J, O, H, N. It was a character level tokenization. Okay, so here only you can find the answer. Whatever I am speaking, smaller units, down text into smaller units. Okay, as such as a word or subword. This is what. Okay, so next parts of speech tagging. We in NLP normally it is known as POS tagging. We know what is tagging. Just now, on the inaugural speech, our principal sir was saying about the Facebook tagging to post here. So, parts of speech tagging involves assigning grammatically category. Now, what is the category? Grammatical category? You can see here noun, word, adjective, and so on. Each word in a sentence that has to be predicted. What is that? Whether it is a noun or pronoun, whether it is a word or conjunction or preposition. So this is what we need to teach the system by using the machine learning algorithms, machine learning formulas. Then the system can train and it will generate. Okay. So named entity recognition. Have you heard about this one ever? Here, when I say COCSIT, it is an organization that is named entity recognition. A person, place, organization is known as named entity recognition. Okay, this is what. This is what you can see here in the bracket, such as name of the people, organization, and locations. That is NER. Okay. After NER, Srikant goes with syntax and parsing. Okay. Understanding the syntax and structure of the sentence in NLP, parsing involves analyzing the grammatical structure of the sentence. And semantic analysis focuses on extracting the meaning from the text. What type of meaning is there? Okay. So I'll move further. See here. It's a very beautiful example. What is this? Homily. Same word. Words that have the same spelling or pronunciation but different meanings. Example: bat, flying mammoth. Bat अपने कशाला बोलतो? क्रिकेट पण नाही. अजून ते बीचवर रडतं ना काय पक्षी? पडवा. Okay. A bat is a sports equipment or it is a mammal? This is what? It is ambiguity. Of course. Okay, we human beings, again we are also confused. What is that? But we need to train the system. It has to extract the meaning referring to the sentence. Okay, what is the next one? Policy. A word with multiple related meanings, for example, bank can refer to the financial institution or a riverside. This is what the confusion. It is not a natural language. Language is also very confusion. We need to understand that one. That's why I have given two components, NLG and NLU. Natural language understanding, natural language generating. Okay. So we come to the part. So structural ambiguity. Okay. Ambiguity that arises due to the structure of a sentence. For example, I saw the man with a telescope. Here it is unclear whether the speaker used a telescope to see the man or the man had a telescope. Okay. I'll utter a statement here. Okay. So please try to extract the meaning. I am starting now. Concentrate. I saw it, saw, such a saw, I never saw a saw. What do you mean by this? Madam is coming into the point. I saw a saw. First saw means I have seen. Saw means the लाकडाचं हे असते ना कटिंग त्याला saw. See saw is. Okay. So I saw a saw. Such a saw I never saw a saw. Like this. So that one. The same thing, here it is unclear whether the speaker is using a telescope to see the man or already the man had a telescope. Okay? Attachment and ambiguity in a grouping words. Okay? Words in a phrases. For example, I saw the painting of the man with the telescope. It is unclear again whether the man or the painting has the telescope. Okay? Semantic ambiguity. Very important. WFD. Word sense disambiguation. Word sense disambiguation. Okay? So determining the correct meaning of the word based on the context. For example, in the sentence, I need a break. Now focus on the word only. What is that? Could be a pause or a fraction also. Isn't it? So this is what? Word sense disambiguation. WST. All these are the components of natural language processing. So when we teach the system, we have to teach these things earlier. Then it will give us the correct results. Okay? Reference resolution, resolving pronouns and other referring expressions. Okay, to correct other antecedents. For instance, in the sentence, John saw the car and called police. It was stolen, determining whether it refers to the car or something else. So this is how certain things are there that are need to be clear very well while writing any machine learning algorithm or a program. Okay, so we'll move to the further. Pragmatic ambiguity, speech acts. Understanding the intent meaning behind an utterance. Utterance means ucha. Okay, pronunciation. Okay, for example, phrase, could you pass the salt? This is my phrase. Might be a request or simply a polite way of saying you want the salt. Okay, this is all. So implication, drawing inferences from the base of context. Okay, and background knowledge. For instance, some student passed the exam implies that other did not. Because I have used the word called as some student. Means out of 10, 8 have passed, 2 might have done not. Okay, so this is what implication. Now, this is the flow of natural language processing. It starts with input sentence. The sentence can be anything. Okay? Sentence can be anything. As I said, John is going to school. So that this is my input now. So, morphological processing, syntax analysis, lexicon and grammar. We need to find noun, pronoun, verb, adjective, all those things. Okay? Semantic analysis. Then pragmatic analysis, the last one is the target representation, that is the tree, what we are getting as output with the classification of complete grammatical. Okay, so this is all. Corpus, as I said, it is a massive database, huge database, language databases. It is a large and structured set of machine readable text that can be produced in a natural communicative setting. Its plural is corpora. Plural. Corpus is a singular. Okay. So they can be derived in many different ways. Okay. So I would like to tell you how the databases are. Okay. These two are the researchers. What they have drawn. Leach and Weber. Okay. So again, according to Leach in 1991, corpus is a sort of representative of the language variety it's supposed to be. Okay. So here, finding the base on the generalized as a different variety of languages. Okay. And according to Weber in 1993, he refers to the context expense which sample includes the full range of variability in the population. So here, this is what. Go through this page, just have a look. Okay, 1960s and 70s, Brown and Law, size in word, 1 million words. This is the database. Okay, so this 20 million words. British National Corpus, 100 million words. And the Bank of English Corpus, how much? 650 million words. Now, working with such huge data, we will get good results. पाच and 10 स्टेटमेंट घेऊन आपण प्रोग्राम देण्यात काही अर्थ नाही. असं खूप मोठा डेटाबेस लागतो. Okay, so this is how the corpus science, linguistic resources. You can Google it, you will get these things. Okay. Now stages in NLP. First one, tokenization. What we are doing, as I said just now, we are breaking the words. Okay, in a smaller units, character level or word level or sentence level. Okay. Lowercase, converting all characters to the lowercase to ensure the uniformity in a sentence. Nothing should be capital. If everything is capital, it is okay. If everything is in a lowercase, that is also okay. Removing stop words. आता हे थोडंसं प्रॉब्लेम करते आपल्याला ज्यावेळेस आपण प्रोग्रामिंग. The second, the example, the and the keys, we call them as a stopwords. Okay, stopwords. Next, stemming and lemmatization. Difference between stemming and lemmatization. Okay, stemming also performs, lemmatization also performs, but lemmatization performs more good. Okay, so reducing the words to the base, or we call that as a base word, or we call that as a root word. Root or base. I have used a word called as a peck. Peck is my base word. Pecked and pecking is the alternate word for that. Okay, that differs according to the statement. Okay. So if you are going in a past, you will say pecked. If you are referring to the current, pecks. If you are referring to the next moment, pecking will come. Like that. So stemming and lemmatization. Next, parts of speech tagging, parsing, and any other. As I said, this is sentiment analysis. Okay, this is the another part, whether the person is positive or negative or neutral, depending upon the comments. Nowadays, we see the many projects coming on the Facebooks and Twitter, sentiment analysis of customers, sentiment analysis of actors. Okay. So how they are behaving, how they tweet, how they comment, all these things. Opinion mining, extracting subjective information from the text to understand public opinions on the various topic. I will post something on the Facebook, like the opinions the people should give. Some may say good, some may say bad, some may say very good, some may say excellent, some may say it is not nice. So these are all the things. Chatbots, we know very well. Okay, virtual assistants. Many times, if you go to the Edureka or some learning management systems, suddenly a chatbot will come. How can I assist you? How chatbots are created? A number of questions are being uploaded into the chatbot. We don't know which customer may raise the question. According to that, it will go and search from the questions what is the suitable answer to give this for this question. Like that, while designing the chatbot, we have to keep in the mind how many number of questions the customer can brag, how many number of things he will put it on. Okay, like that the chatbot. Machine translation, automatically translating the text from one language to another language. So we all are using Google. Whenever we find any PDF or any text, we immediately translate that word, that file. Okay, translation. So speech recognition, no need to say anything about this. You know very well, Sudhir Bhosle, the great singer and the great mimicry person. So there was a movie called who was the actor Amitabh Bachchan and Hum Picture. He sang that song in his voice. Now, how the system will identify he is Amitabh Bachchan or Santosh Bhosle? Okay, so there is a pitch, what we will call. Now, I am delivering this session. Sometimes my tone goes high and my tone comes down also. There is a pitch. Based on that one, we can be able to identify. Okay, so converting spoken language into written text. Nowadays, in ChatGPT, the new version Gemini and Torah, if you say a single statement to the ChatGPT, the higher version Torah, if you give a input, a gentleman is walking in front of the Zulpe's cabin. They just you give this statement. Okay, it will generate a picture for video, from text to video. Still, it is publicly, it is not. Still, under it is many experiments are going on. Okay, so like that, there are many things are there: transcription services, voice assistants, and so on. So these are some applications where NLP use, healthcare application, financial sentiment analysis, legal document analysis, even in the stock market prediction. Some of my colleagues every day they will sit from 9 to 3, which share is going up and which share is coming down because they have invested in that one. So this is what? Education, e-learning, social media monitoring, fraud detection, content generation. Okay. Let's skip this one. This is the pipeline for natural language. Step 1, sentence segmentation. That is tokenization. Tokenization, sentence segmentation. Word tokenization. Okay, word by word you are breaking that one. Next, stemming. Next comes stop words analysis. Which are the stop words from the sentence we need to identify. Okay. Dependency parsing and parts of speech tagging. POS tagging means in that sentence what is noun, what is pronoun, what is adjective. We need to identify that. Now this is how. My statement is London is the capital at most parts. Proper noun, word, determiner, noun, conjunction, adverb. This is what I am expecting from that particular statement. Okay. Can you read the text which is highlighted in the red color? Okay. Now it does. So here the primary goal of tokenization is to represent text in a manner that is meaningful. So the word should be meaningful for machines. Okay, and by converting text into tokens, algorithms can be more easily identify the patterns. Okay. Now singularity entity. Consider the sentence chatbots are helpful. This is our input sentence. What we have seen in the flowchart in earlier slides, what I have shown. Now this is my input statement. Chatbots are helpful. So this is how I have kept it. When we tokenize this sentence by words, it transforms into array of individual words. See, from English we are coming to maths. Okay. I will convert this into numeric values. Chatbots are helpful. How many words are there? 3 words are there. Coming to the point, let us see here. This I have done it. What is this now? Character level tokenization. Each character is isolated. Okay, C, H, A, P, P, O. So character level breakdown. Okay, if you move to the next part, it is quite like this. Okay, in tokenization, how many types are there? See there. In tokenization, the first one is word tokenization, character tokenization, and sub-word tokenization. Now, in simple tokenization means you are breaking the characters, word, sentence. Okay, so word tokenization, word by word, character tokenization, character by character, sentence, sub-words. Okay, so this is what. So when you take as a sub-word tokenization, chatbots could be tokenized into chat secretary and bot. Subwords. Within the word only you are breaking that. That will become a subword. Okay? Now here, my sentence, my input sentence is the quick brown fox jumps over the lazy dog. This is my input sentence. See the word level tokenization. What is happening? What is happening? Each word is broken down. Okay. So have a clear look here also. What is the last? This is full stop. punctuation marks are also to be identified. Either it is a code, full stop, exclamatory mark, question mark, whatever it is. Okay, I'll show you some of the examples how sometimes machine how it makes an error. So this is the first word, the brown fox jumps over the lazy dog, double quotes, and okay, this is all. So I'll come to the part, you can see here. Sub-word level tokenization, chat bomb. I am separating chat separately and not separately. This is breaking down. So, here, whenever you come, this word will be coming very frequently. Morphological language means structure of the language. Either it is English, either it is a Marathi or Hindi. Every language is having a structure. Okay, so depending upon. So the chat bot is broken down into chat and bot. Now this is character level tokenization. What is my input? HELLO separate. This is for character by character we are breaking. Now search engines, tokenization use cases like Google search engines, okay, machine translations and speech recognitions. Can be used with challenges and limitations. Okay, English or text corpus written in English or French or any other language. These languages separate the words by white spaces or punctuation marks. So, unfortunately, this method could not be applicable for other languages like Chinese, Japanese, Korean, Thai, Hindi, Urdu. Still, the research is going on. Okay, these are the languages. So, if you see here, this part from here to here is Arabic. Okay, I have converted my Arabic into English. Okay. How will you make it a natural language? These are the libraries. NLTK. Okay. Go to the Jupyter or Google Colab, import NLTK. You will get the natural language toolkit. You can use that one. Next, SPAS. Okay. This is another Python based NLP library. Okay. Third, tokenizer. It is a pre-trained model with these tokenizers excels in the context-aware tokenization. Okay, NLP with BERT. BERT is a pre-trained model. Now, these are the screenshots where I was working on the Google Colab. I took that sleeper, I pasted this some of the code. Okay, the white space tokenization. So before coming to that one, there are certain tools available for tokenizing. NLTK you can use. You can use text to block, speed, JAIN, and Keras as well as TensorFlow. Keras also. Okay. Now in these slides, I go a bit faster because another session needs to be covered. What is my sentence? Who will read this one sentence? I was born in. When we write tsunami, we write the first word is a treaty. Like, okay, in 1995. So now see here. This is the variable context dot split function. Now what this function will do? It will split the words. It has split it. This is the output. Built-in functions. Okay. So this is how. Now with comma. There is a comma here. Okay. So sentence dot split comma. So it has split the names. You can see the errors in the next slides also. So NLTK, Natural Language Toolkit, it is an open source Python library. Okay, You can use this one directly. Why it is in WordNet along with the set of text processing libraries for classification, tokenization, stemming, and tagging. It can be used for NLTK. See, what I have done, import this toolkit, okay, in Jupyter or Colab from NLTK.tokenize import. Now, what I am importing here? Word tokenize, I am importing. Sentence tokenize, I am importing. Tree bank, word tokenizer. Word punctuation tokenizer. Print tokenizer. MWET tokenizer. Okay. MWT means multiple word expression, something like this. It is there in this line. Okay. Now, what is the input text here? O, comma, is the only thing stronger than fear. Part is there. Okay. Hash, O, hash, amal, dot, and now it is closing here. Double quotes. Okay. How many tokenized we are downloaded? From this library, you can use these many things. Got it? Okay, you can use word, sentence, remain, punctuation, fit. Fit in the sense, in the WhatsApp, someone sends us a message, you will send them thumb symbol or upward direction, like that. There is a fitting what we call. I'll show you here. Now, print word tokenized text, because this was this variable I kept the sentence. O, comma, again, comma is the only thing stronger than fear, exclamation mark, hash, O. What is the error here? What is the error? Huh?
Comma, like a word dot like.
The error is it has not separated isolated. Okay, the next slide you can see very clearly that. Now see the output. Is it? This tokenizer splits the sentence into words based on the white spaces and punctuation. Well, it is not like that. If you see, it is there. The output print sentence tokenized text. I am printing. Again, I am getting it. Actually, it should be isolated, no? It should be separated. But here it is not like. If you go to the next slide, you can see very clearly so that it has been separated. Okay? So, here we could notice the difference between considering that ML.M, a word in a word tokenized, and split in a word punctuation tokenized. Punctuation also separated. Okay. So, text block, word tokenized. You can use text block. So, on the command prompt, pip install text block. Okay, it will install the toolkit if you do it like this. Next. Now, here what I have done, from text block, I am inputting the text block, text equal to, my input statement is, but I am glad you will see me as I am. Above all, I wouldn't want people to think that I want to do anything. This is my what? Input statement, sentence. So, block object equal to text, block text, the big text I am calling here. Okay. Word tokenization I am doing to see all the tokens, print text words, to count the number of words in this sentence, print length, text underscore words. This has been tokenized and total number of words are how much? Okay. The earlier was using NLTK. This is using text block. So this is how. 3-bank word tokenizer. Here.
Emojis. Emojis are also separated.
Yes. Okay. See in the first statement, this is my input. Don't take cryptocurrency advice from the people on the internet. You are the same. These two symbols should be isolated. So that's how what I mean tokenizer. Quit tokenizer function I am using. But whatever they have quitted, that are isolated. So quit tokenizer function. Just I am printing print tokenizer dot tokenize quit. Okay. This one. So what it is doing? It is separating all the words as well as the quits. This is what highlighted here in this. Okay. Are you getting this one? Now here, what I mean MEW, multi-word expression token. MET. सुरुवातीला आपण सगळ्याच लायब्ररी डाउनलोड केलं होतं त्याच्यातलं एक कंपोनेंट बाहेर काढलं. Okay, so Hunger Games. And what I am doing, I am clubbing this one. Hunger Games. From here and here. So you can, all ready-made functions are there, just you have to think and write it. Spacing, this is what, with the spacing. The output what I got it is. Token of IDS refers to IDS or position of a token with original text. Now this is with JAIN toolbox. Okay, so you can use it like this. It is also a Python library. This is with Keras, by using Keras. This is the output, three output. Okay, sentence, noun phrase, verb phrase, determiner, verb, position phrase, and this one. So this side, this is the code, and that is the output. Okay, this is the code. What is the text here? We are using here spacing toolkit. Okay, import spacing. NLP equal to spacing dot load encoder. My input text is the quick brown form. Now what I am doing? I am using another variable called as doc equal to NLP text. This is what NLP text. Or token in doc print the positions. Okay. Now these are the classifiers that can be used for natural language processing. Not limited to this one. Still there are many. Okay. Just I have kept here conditional exponential classifier, decision tree, max extent classifier, naive bias classifier, Vika classifier. Okay, so there are different classifiers. You can use SVM also. You can use neural network. There are many machine learning classifiers are there. So still only now it is 3 only. Just 5 minutes are there. See here. Coming to the course of machine learning sector, we defined a simple training orders with 3 binary features. Okay. A, B, C, and 2 labels. What are those? Features किती आहे? 3 and labels 2. म्हणजे क्लास आपल्याकडे 2 आहे. एक X क्लास आहे, एक Y क्लास. फीचर. Okay. From NLTK, so I am using here natural language of .text classified fixed import setup module. Okay, import NLTK. Now you can see here. I am training now. Okay, so this is my variable train equal to A equal to 1, B equal to 1, C equal to 1. My label is. Which type of learning is this? Supervised. Because or A equal to 1, B equal to 1, C equal to 1, I am giving a label as this. Now this function knows that when all the values are 1, this will fall into the category of Y. Okay. Now A equal to 1, B equal to 1, C equal to 1. X. A equal to 1, B equal to 1, C equal to 0. Y. So like this is the data that has been given in this frame. Okay. You are training that. Now, just this it is very interesting. What was that? What do you mean by unseen? These two things we have not used in the training. We have not used in the training. And these two things, the function was seen 3 times. How many times? A is input A equal to 3, B equal to 1, C equal to 1. That has, it knows, it has seen how many times? 3 times. And this pattern, it has seen 1 time. But these 2 patterns it has never seen. Still we are given a label to that. So unseen data, seen data can be easily identified. For example, there is a crowd of 10-15 people. Assume that or imagine that one of our family member, mother or who is standing in between the crowd and we are at the 10 feet away from the crowd. When we see them, how much time we will take to recognize our family member? Just a few seconds, that word few seconds also fall down. Okay. So, but only one our family member is standing and we are taking less amount of time because we know. What about the rest of the people? That is unseen data. Okay. So this is how. When the pattern, now I came here, many people mostly, some who are new, they have joined, they don't know me. For the persons who are already, I work with them, that is seen data of Chowhan is there. Unseen data, the persons who don't know. Okay. So this is how that I want to say. 2 levels, 3 features, 3 binary features. 0 and 1. Okay. We took it like this. So probability distribution. So this is what classified features is given. Hangarge shape bonus point, stemming, the benefits of stemming in NLP algorithm, it summarizes, it reduces the number of words that can serve to the machine learning. It assists eliminating out of vocabulary, what we will call. For example, vocabulary does not contain the word oranges. One can use the stem word as a point. What is that? Can you see here? This is what? Oranges. And this is what is missing here? Orange, only orange. Okay. So one can use the stemming word. Stemming was a gay word. With the car difference types of stemmer, focus stemmer, snowball stemmer, fantastic stemmer. You can use these libraries. Okay. A program is stemming circuit. This example is overstemming and understanding is also. Today the time is not permitting, some other day this is the elbow method. Variance clustering. Okay. So here applying variance clustering from Secretory cluster. Lemmatization. See, lemmatization is the process of reducing the word to the base root form. This is what the difference. Okay. So peck is the root word. Pecky and peck. That is not a root words. They are the alternate words for. This is what it is used here. So with this, there are many things are there. Time doesn't permit. So I don't know how far I came to the point. So how it was, I don't know. Okay. So thank you for anything. So
Thank you.
anything if you want to ask, you can ask.
Thank you so much, sir, for your words. It was very informative. Like we got everything, like text processing and NLP with so many examples. If anyone is having doubts or queries, they can ask me.
Application area is simple analysis.
Okay.
Many applications.
There are many applications. Many applications. Among them, one is study.
Production is doing on the same thing.
Okay. Okay, with your permission, I am signing off.
I request Secretary Jagtap sir. I request Samolkar ma'am, please come and thank Chowhan sir with a memento and a certificate. Samolkar ma'am. Once again, thank you so much, sir, for your informative section. It was very, very wonderful and meaningful and informative for all the students attending this class over here. Thank you so much, sir. After this, we'll have